Hey everyone, all right, so we're going to do notes 5. So we're going to do absolute value with equations and inequalities. So the biggest thing is that we're going to apply what we already know and just tweak it a little bit because of the absolute values. So that's the biggest thing. You're applying everything you've already learned. So absolute value is really the distance from 0. And that distance is always positive. So we're always going to have two different answers. You'll have two answers specifically when you have equations, and then you'll do something different for your inequalities that you'll have like a solution set. Okay, I'm just going to read that. So I want to take a look at the following equations. We'll start there. So for number 1, we have the absolute value of x plus 2 equals 9. So the biggest thing is just like parentheses, you need to get the absolute value by itself first, and then you can start figuring out what goes inside. So I'm going to move my 2 over first because it's adding, so the opposite of adding is subtracting. They're inverses. Bring down my absolute value, and so the absolute value of x equals 7. So if you remember, absolute value makes everything positive that's inside once it's simplified. So really what we have here is x equals 7, and we have x equal to negative 7. And we could also write that as x plus or minus 7, because if you put in a negative 7, it ends up being positive because of the absolute value. So this is what we're going to do. When we get to the point that the absolute value is by itself, we're going to split it into two different equations or inequalities. Okay, so we're going to walk through that together. So I want to go ahead and I want to do number 2 with you. So I'm just going to scroll right over here. So we have number 2 is 3 times the absolute value of 2x minus 1, whole thing minus 5 equals 10. So you have to get this group by itself completely. So the first thing I'm going to do is I'm going to add over the 5. Okay, I need to get the group by itself. I can't divide by 3 yet because I have that 5 there. So these are inverses, bringing down my absolute value, adding, so I have 15. Now I can go ahead and divide by 3. Okay, these cancel. And now you have the whole absolute value by itself, and it's equal to 5. So at this point, you're going to take the 2x minus 1 out of the absolute value and split it into two different equations. And when we do that, one is going to be positive, so this is the positive one. And then on the right side, we have the negative. We're going to make that 5 negative. And now it becomes a two-step equation. Okay, so now we can solve it. So when we add 1, trying to just fit it in here, and then divide by 2. So we add 1, we get 6. Divide by 2, we get 3. Okay, add 1, we get 6, and divide by 2, so we get 3. Then same thing over here, same process, we're going to add 1, so 2x is going to equal negative 4, so x is going to equal negative 2 here. So now our answer here, we're going to have x equal to negative 2 and negative 3, because if we plug in both of those, we will still get a positive 10. And we should check it to make sure. So negative 2 times 2 is negative 4, minus 1 is 5, absolute value of negative 5 is 5, 5 times 3 is 15, minus 5 is 10. So same thing with the 3, 2 times 3 is 6, minus 1 is 5, and then you get the same process. So I'm going to leave this up here. I'm going to just zoom out just a little bit because I want you to go ahead and do number 3 on your own. So go ahead and do that now. All right, so when you're done with 3, you should end up with x equal to 13 or x is equal to negative 17. So you're going to add the 10 over first, and then you'll separate into the two equations that you have, remembering that this 30 for the second one has to be negative. So if you didn't make it negative, then you got the same answer twice. So keep in mind you need to make sure that when you split the absolute value for the equation, you have to make it the opposite. You have to make what it was equal to the opposite. Okay, and then you can go ahead and solve. So that's for doing it with an equation. So I want to take a look at number 4, since that's a word problem. I think we should take a look at that together. So starting from 100 feet away, your friend skates towards you and then passes you. She skates at a constant speed of 20 feet per second. Her distance d from you in feet after t seconds, okay, is given by this equation. Okay, at what times is she 40 feet from you? Okay, so we have to set up this equation and solve. So we already know that we have the absolute value of 100 minus 20t. Okay, so then we have to look at what is it equal to. Well, they give us this 40 feet. Okay, is that a time or a distance? Okay, it's 40 feet, so it's a distance. So we're going to plug that in for distance. So anytime you have something like that, look at where you need to be plugging it in. Okay, look at where that number goes. Substitute it in, and then we're going to solve. So we're going to take this absolute value, we're going to take it away. One of the 40s is going to be positive, and the other one is going to be negative. Okay, and then it just, again, it becomes a two-step equation. So I want you to go ahead and do this part on your own. It's great additional practice for you. So go ahead and do that now. So for number 4, you should get the time. T is your time, so T equals 3 seconds and 7 seconds. So she was 40 feet from you at 3 seconds and at 7 seconds. Okay, so T equals 3, T equals 7, you should label your units. Okay, so I want to go ahead and jump down to number 6, and I want to take a look at it. We're skipping 5 for now. So for number 6, we have our absolute value. And we need to solve for x like normal. So we're going to go ahead, just like normal, we're going to add 5 over, because the group isn't on its own, so we're going to add 5 over. So we have absolute value of 3x minus 6 equals negative 2. Okay, so at this point you're probably saying, well, I'm going to go ahead and split because that's what I need to do. Well, technically at this point we are done. And we are done because an absolute value cannot equal a negative number. 3x minus 6 can equal a negative number, but an absolute value that is completely by itself cannot equal a negative number. Okay, so at this point, what you would say is no solution. Okay, you would say no solution because this absolute value symbol, with it still there, okay, with that still up, cannot equal a negative number. The equation inside can. This is okay. You've seen that a million times. But the actual absolute value itself can't have this negative in front. So you're going to say no solution at this point, and that's your answer. It would be no solution. All right. So at this point, what I want you to do is I want you to do number 5 on your own. Okay, so once it loads up, I'm going to leave 6 in the screen. You're going to do 5 on your own, so go ahead and do that now. All right, so for number 5, you should have said no solution for the same reason that we said no solution for number 6. When you get the absolute value by itself, it cannot equal a negative number, whether it's a negative fraction, negative whole number. If you didn't notice it in the previous step when you subtracted 12 over, that it was a negative 2, even if you divided by 3 and then noticed, hey, I have a negative fraction, that is still a no solution. So hopefully you noticed it. It does happen. So double check your work and make sure you didn't make a mistake, but it does happen. So don't let it trip you up. So now let's talk about inequalities. Inequalities, we have, for this one, we have an absolute value of x is less than 2. So to do inequalities, the best way to do it is just do it by practice. So when we have the absolute value of x is less than a number, or the absolute value of a group is less than or greater than, or whatever the case may be, this is how you're going to do it. So you're going to drop the absolute value and you'll have x is less than 2, okay? But you also have to take that x, flip the inequality, and make it greater than -2. Okay, so opposite number, opposite symbol. And so a good way for you to check yourself and remember is that when you've got less thans or less than or equal tos, those guys will always be an and inequality. So we learned in the last video, greater than or equal tos will always be ors. Okay, so if that's helpful for when you need to know if you have an and or an or, when you have the inequality, regardless, when you go to split it up like we did with the equations, one of them will be what you started with, and then you can solve from there if you need to. And the other one will be the opposite inequality. So if you have less than, you now have greater than, and then the opposite number on the other side. So now we do have an and, so we can say that -2 is less than x and x is less than 2. So we have this and inequality that we can go ahead and put on our graph. So they're both open dots and we can shade in between them. So anything you put in there will be less than 2. Okay, so if you're unsure if you did it right, if you put in 1 is, or -1, 1 is less than 2. Absolute value of 0, which looks like LOL, is also less than 2. Okay. Now remember that they're not included, like the 2 and the -2 are not included because 2 cannot be less than itself. Okay. So the big important thing that you really do need to get out of this next part is what happens when you flip, which I'm highlighting right here, and that you still have to split the inequality, flip your symbol, and change the sign. So we're going to keep practicing that. So on number 8, okay, solve the inequality and graph the solutions. You need to make sure that you get it completely by itself. Okay, the inequality has to be completely alone. So we're going to divide out the 8. So the 8 goes away. I'm going to start way over here. Absolute value of x plus 4. We divided by a positive number, so it's still less than or equal to, and now this becomes a 1. So now, just like when we did in equal signs, when we did our equations, when we did equal signs, when we did equations, we're going to split what's inside, keep the original, but the second one, we're flipping the symbol and changing the sign of what it's equal to. So then when we go to solve, we do the same steps to solve, but then we end up with 2 different inequalities to make our graph with. So I'm moving stuff, moving the 4, moving the, subtracting it out. So now I have x greater than -5, and I have x less than or equal to -3. So if we wanted to write this out, I have -5, which is less than or equal to x, which is also less than or equal to -3, which is just what it said, that we've spent a lot of time talking about how to read it from left to right and right to left. If we're reading inequalities, we can read them from left to right and right to left. So just make sure that you're doing that when you're writing your and then we can create our graph. We have solid dots because they are included, and then we have shaded in between. If we were going to do interval notation, we should have brackets, and then we can put our -5 to -3. Okay, so that's an inequality. Okay, that's what we're looking at here. So jumping down to the next section, I did not, or I do have the graphs in there. Okay, never mind. So it says solve and graph the inequalities, and then solve the equations if you have equations. So if you have inequalities, you're going to graph. I'm also going to add that if you have inequalities that you need to do interval notation. Thanks. I think that's important enough for us to keep practicing. You guys are doing a great job. Okay, so I want to do one more together, and then you can do two of them on your own. So I want to take a look at number 9. This is already by itself this absolute value of 2c minus 5. There's nothing being added, subtracted, multiplied, or divided. So I can go ahead and split. Okay, so I'm doing my split. So 2c minus 5 is less than 9, and I have 2c minus 5 is now greater than negative 9. Okay, so I have adding 5 over, because that's the opposite. They're inverses, inverse operations. So now c should be less than 7. And then I'm doing the same steps on the other side. So 2c is now greater than negative 4. And when you divide by 2 here, c is still greater. We don't flip it because we divide it by a positive, but it's greater than the negative 2. So here, because we have a less than, that means we have an and equation, so we can combine it. So negative 2 is less than c, which is less than 7. So we can graph it and we can do interval notation. So negative 2, 1, 0, 1, 2, 3, 4, 5, 6, 7. I have open dots because neither of them are included. And then I'm going to shade in between. Okay. And then for my interval notation, I'm not including negative 2. And I'm also not including 7, but the range I have is between the two. So that's what my interval notation looks like. Parentheses, negative 2, comma 7, parentheses. So what I want you to do is I want you to do number 10 on your own. You have an inequality, so you need to solve, graph, and do your interval notation. And then I'm going to have you do number 11 on your own just to keep practicing the equation. Okay, and we'll do number 12 together because that one's a little harder. So go ahead and do 10 and 11 on your own. Okay, so go ahead and do that now. All right, so for number 10, you should have t is greater than or equal to 4, or t is less than or equal to negative 12 over 5, which actually works out to be negative 2.4. So in case that's what you have. This isn't or because this is a greater than or equal to, so it is or. The graph is down below. You're including 4 and negative 2.4. Your interval notation is negative infinity to negative 12 over 5, both in parentheses. Your U for union, a bracket for 4 because you're including, and then you have the infinity with the parentheses. So that's for number 10. So make sure you check your work and ask any questions if you have any. So then number 11 was just an equation. So you needed to add, or you needed to subtract the 1 over, then multiply both sides by 4. Okay, multiply both sides by 4 to get rid of the 1/4. So this becomes a positive 4. And then when you split, you have the 2x minus 6 equals 4. And then you also have the 2x minus 6 equals negative 4. But ultimately at the end, you should get 1 and 5. Okay, and then I made an executive decision. We're not going to do number 12. I don't think you're going to see one like that on the Regent, so I'm going to spare you. You'll see something like that maybe in A2 and definitely in pre-calc. So I wouldn't worry about that one for right now. But if you do have any questions in the meantime, go ahead and reach out. Other than that, have a great day.